So my name is Evan. I'm a long-time contributor to Mojaloop projects and currently a full-time contractor with the Mojaloop Foundation. Over the past few years, I've worked across various parts of the Mojaloop stack, like from onboarding flows to interaction, like to integration tooling, and the core infrastructure. And yeah, so I'm also a co-founder of Skynex, where we built an edge-native platform used in sectors like retail, telco, and financial services. And lately, I've been leading effort to apply Skynex platform to Mojaloop and to the CBS deployments that's specially focused on the enabling DFSP onboarding on low resource and field-ready environments. So think about like whether we run a router, how would you do if connecting to the Mojaloop would be the same experience as connecting a router? The same way as you connect your TV, you can and watch a TV. Actually, you can connect some box and immediately be connected to the Mojaloop ecosystem, Mojaloop network. And whether you're running a paper-based rural SACCO or Excel-driven microfinance institution or a modern core banking system, the platform, the Edge platform, Skynex's platform can deliver this Mojaloop connectivity. So the idea is that we are focusing on the integration primarily, and it means that whatever the stack is on the client side, the integration part is done entirely on the edge nodes on the device, basically. So making the adaptation of this kind of solution, it actually opens entirely new markets for Mojaloop. Like institutions that want to participate but need a simpler path to connectivity. Our Edge platform already powers, critical infrastructure across retail, like transportation, government sectors, and now the Mojaloop is another use case that we saw might be really interesting to adopt. So yeah, so here's what makes our approach different. So as I mentioned, like we recognize that DFSP exists at every level of technology maturity, from rural cooperatives still using paper ledgers to sophisticated banks running Mambu or T24. And instead of forcing everyone to adopt same technology stack, we provide integration models that match their current capabilities. So a paper-based SACCO can upload customer lists via CSV. A bank with the FINERACT can use a secure path-through connection with the like as a router with our box. And the beautiful thing is that DFSP can evolve their integration over time. So they can start with the simple CSV gateway and migrate to the REST adapter, eventually move to a full pass-through, like all on the same platform, basically. So let me show you the hardware that makes this possible. So this is the Edge node, and it's not like a typical mini PC. It's a purpose-built hardware for critical infrastructures like financial services, financial providers, deployments, and is deployed in challenging environments. So it has a funnels design, means like no moving parts to fail in dusty conditions. It has a secure boot that ensures that the device hasn't been tampered with. It has encrypted storage that protects sensitive data even if the device is physically compromised. And for mission critical deployments, you can cluster 2 or 3 nodes with the automatic failover, and they run like in active modes all the time. So the entire system is designed for remote management, configuration updates, security patches, and profile changes all happen over the air with the rollback capabilities. So, as I mentioned, this is designed for real-world deployments challenges. We've deployed probably like multiple hundreds of these solutions across different environments, including those that were during wartime conditions in Ukraine, right? So, like rural branches with the unreliable power, agent locations without IT support, regulatory environments that demand compliance. So we solved these problems across multiple sectors. So let me show you what's running inside each node. So we've designed a modular software stack where the platform components are standardized and managed by us, while the upper level software like the CBS integration layer is pluggable. So every node runs hardware Linux with our Skynex Edge platform core. On top of that, we can provide different workloads. So we can adopt Mojaloop SDK adapter, reconciliation engine, everything backed by the over-the-air update agent, TLS gateway with full observability. So the key insight that the CBS bridge, this is where the system integrators like plug their custom code to connect with a specific core banking system. So whether it's a REST API, to like Mambo, a database connection to legacy system, or even CSV file, it's all supported. So the platform can handle all this complexity, like security updates, monitoring, Mojaloop protocol compliance. So integrators can just focus on the business specific to each DFSP needs. So let me walk through the zero-touch onboarding, what it looks like. So this is the process of pushing a DFSP profile to a remote device and having it become a trusted Mojaloop participant in minutes, basically. And the beauty of this approach is that complete elimination of manual steps. So you don't need VPN setup, no manual certificates management, no USB sticks, no on-site technicians, just a profile pushed from our control plane to the device, and it handles everything automatically. And what's powerful is that this maintains all the security guarantees of traditional Mojaloop deployments, while drastically simplifying the operational complexity. So let's break down what happens technically during this onboarding process. So the device receives a profile, it generates a fresh key pair, submits certificates, signing requests to the CA, received signed certificates, JWT tokens, then publish those tokens back to the services. Like you can think about like account lookup service, for example. And all this happen automatically, securely. You don't need to even maintain a separate vault instances like or key clock. You don't even need to do a manual certificate management. So because of the plugin infrastructure that's built into the platform that can support the whole infrastructure requirements that the integrator or other party would like to integrate into the DFSP. So let me just show you how it scales in real world. So our deployment model range from just a single rural kiosk serving small setups to enterprise clusters. And the beauty is that is the same platform. So like you're not locked into a specific deployment size. So a rural SACO can just start with one node and then grow like to more devices. So it's the unified platform from the hardware perspective and from the software perspective. So at the other end, central banks can even deploy regulator mirrors nodes to monitor entire Mojaloop network in real time. So it's like the same platform, but just different size, but same management tools. And the key insight is that whether you're running, again, like paper ledger or full-fledged CBS, whether you're serving like 100 customers or 100,000 of customers, and I mean the path to Mojaloop is identical. You plug the device, you configure the profiles, and yeah, you start moving money after that. And like we believe that financial connectivity should be as easy as internet access. And Skynex can be that router, the missing compliance that can give any DFSP a secure zero-touch path into the Mojaloop. And yeah, so this is like not theoretical. This is like already works in the field, and it supports like really different sectors, primarily across like in Ukraine, like starting from retail up to the transportation, trekking, even like face recognition requirements. So everything runs on the same platform, providing those infrastructure requirements and durability that customers require from that. And yeah, just want to quickly show how this platform compares to other options. Not just in price, but how easy it is to run. I mean, cloud system can be easy to start, but they are hard to predict. They need like DevOps and stable internet connection. On-premise servers, they're kind of powerful, but they take time to set up. And the Skynex Edge platform offers a third option. So it's like delivered entirely as the hardware as a service plus software as a service. So you got the hardware subscription basically. If everything goes down, you got the immediate replacement from the local fulfillment centers. So it's just like a regular subscription, but it's much more cost efficient than running cloud, running your deployments on the cloud, because cloud might not be reachable everywhere where you need the offline connection, for example. And the on-premise servers, they are hard to scale actually, because you won't know your actual transaction rate, for example, at the start. So yeah, so just to demonstrate how the onboarding might look like from the very early stage up to the receiving device by the DFSP. I want to show you just this route. Okay, let me share another screen quickly. Can PSP use this hardware? If yes, yeah, they surely can use this hardware. I mean, it scales from just a single node. I mean, we always provide two high availability nodes because we understand the hardware might fail, and whether it's durable or not, it fails. So it's minimum two, and estimated costs roughly for a cluster of two devices here in Ukraine, for example, with the 8 gigs of RAM, four CPUs each. So yeah, so it's about like $20 or $25 per month. So it's like half of the price that you usually get from AWS on their platform usually. So yeah, just to give you the idea how it looks like. So let me share the screen. Okay, so this is just to explain, the platform itself is really agnostic. It's agnostic to the use cases in which this platform works. So it either it works in retail, it works in finance, it works in the transportation, in logistics, like in different spheres. And as I mentioned, Mojaloop is one of the most interesting use cases of this application. So this is just, you can think about this as just a skin to our platform that we just built, like renamed some texts here, but the underlying architecture is basically the same. So we recognized that how Mojaloop participants get onboarded, how Mojaloop DFSPs gets onboarded with the help of the partners, the system integrators, is basically the same as we saw in other areas. And so you can see here just an example of the portal that, I mean, this is a production ready one. This is just a demo portal, right? Customized for the DFSP use case. So everything starts from the partner. So the partner is the person who connects DFSPs, finds DFSPs, and connects them to system integrators, and eventually connects them to the Mojaloop. So the partner, whether you're a partner, you can just log in. So I will just use some credentials here. And the partner can register a new DFSP as its role in this whole flow, in the onboarding flow. So it starts from registration, where it provides test DFSP. Let's call it my DFSP. My DFSP. Can select region, business type, the contact name. This can be an email of the DFSP operator. So I'm going to use just a temporary one. Just a moment. So I'm going to just follow the process that a real partner would follow if he wanted to onboard a new DFSP with this portal. So he will enter the contact email of the DFSP, the phone, and then some monthly transaction value. Then he will select the system integrator that will help the DFSP to get onboarded. Again, like system integrator involvement in this process is not strictly required, but it might be required from the regulatory perspective. So let's select this one. So you can see their availability, whether they are available or not to support onboarding of the DFSP. And we can select some deployment timeline, whether we are in rush or we can wait. And we can just click register. So you can see this form just summarizing what will happen next. So because partner is a trusted entity, the DFSP gets automatically approved for onboarding. So DFSP operator gets an email at this time. At this time, the system integrator also receives an email about the assignment of the new DFSP to him, and about the timeline which this DFSP should be onboarded. And yeah, so you see some next steps that will be performed. So DFSP, on the other hand, he will check the email box. He will receive the email from the platform with information about that he was successfully registered, and with a secure invitation link with some information about his entity, his business entity. Additional information about how this process of onboarding will look like, and some contact information of the partner. So I'm going to copy this link and open it in the DFSP. So this is just a DFSP page separated by sessions. So here, when he follows this link, the invitation link, You can see presented some page where he can enter some personal information, the passwords, and he can create an account on the Edge platform. Okay, account successfully created. And now we can just use this email and passwords to log in. So what DFSP will see, this is his dashboard that will be updated as soon as the onboarding process will start. So right now, like his status, you can see it's active. You can see some information about his organization, some telemetry information that will be updated very shortly as soon as he receives the device. And yeah, so the information about his integrator, who who is responsible for his integration. At the same time, if we go to if we think about the integrator, we are going to log in as the integrator. Sorry, not this one. We are going to check the email of the integrator. And you can see that integrator received an email about new DFSP assignment called My DFSP, about the timeline, special requirements, like standard deployments, maybe other type of deployments. And yeah, so integrator can just plan his work with this DFSP. So he will then just logs in to the platform. So I will use the integrator email and the password. So you can see here my DFSP that was added to him, assigned basically. So this is basically the platform that integrator will work in while supporting DFSPs. So I can actually show the demo data, how it can look like, where you can have dozens of these. So you can just, filter by whatever you want. Status, region, type, whether a credit union, MFI, regions, other things. So just hide the demo. So integrator can just switch between those DFSPs, and we'll see some data specific to those DFSPs. For example, I think so. For different kind of DFSPs, even the menu will be different because they will speak, specific language, domain-specific language. So, so once again, as the integrator that logs into the Skynex Edge platform portal, he selects My DFSP, and then he first of all he needs to understand the requirements, and after he understands the requirements of the DFSP, he can request nodes. So So node request is basically the step, the point that triggers the delivery, the shipment of the hardware to the DFSP. So as soon as integrator understands the requirements of the DFSP, whether it's a small one or a big one, he can just provide the necessary quantity, the node type, uh, some kind of like deployment type, whether it's production staging, information about how fast it should be delivered on the DFSP side. So he will enter the shipment information. So like the contact person, the contact email, which might be different than which DFSP operator used. So I'll just put anyone. Some business justification that's also can be made optional. Like once again, these are requirements that we faced in other industries as well. So that's why it's very common actually. And the deployment plan. So these are some description for him as well, and for some history about this request. And as soon as integrator click submit request, node request will be created, and from now on we receive the request to shipment, and we start preparing the shipment of the devices. So for example, in Ukraine, we use the local fulfillment centers to make the delivery as quickly as possible. Also, we've been working in Poland, and we estimated the delivery might take up to like a couple of days, like without like I mean, it doesn't matter whether you are like in a distant area or not. This like couple of days delivery can be met. So the integrator at this time at this point, he will see this node requests for different kind of DFSPs. Some of them were fulfilled already, delivered. Some of them are still pending. And the DFSP, on the other hand, so he can monitor the shipment in an additional page. So he can see the request, request ID, the system integrator, his contact information, and the statuses of the delivery. And delivery is updated automatically from third-party delivery services. So as soon as the device is delivered, I just need to make it manual so you can see what happened next. Just give me a moment. So I'm just going to fulfill some requests. Okay. Okay. And yeah, so we can see the device was delivered. We can track the link on the courier. Some information here about the shipments, and yeah. So at this point, the FSP already gets the hardware physically on hand. And the system integrator can start, so he can also update this page. He can see that 2 nodes were delivered to this DFSP. And he can start to configure the infrastructure for him. So how does it look like? So you can see 2 nodes. So the configuration consists of applying the profile, and that's basically everything that system integrator should have to do. What the profile mean is whether a DFSP runs a core banking system or whether it runs just an Excel. You can adopt a profile for it, for this use case, and you can just upload this profile, which basically tells the device what to do, like what to run, how to behave, and like what ports to expose, how to connect, etc., etc. So again, like updating the profile, let's say like has a MIFO connector, just like updates, and basically that's all. So we can see, for example, in here where I can have some probably devices running. Yeah, so some of them are running, consuming not much resources. So the profiles basically are the composition of the templates that the integrator can customize for every use case that the DFSP wants to operate in. So it might be like, as I said, like a MIFOS connector, a CSV. So a customer can just upload a CSV file, a DFSP, or even an Excel connector. So everything is configured straight from this portal. So there are also the GitOps repo for developers to support the actual configurations, right? The manifests. It can be just Helm, like Docker, even like non-Docker deployments. So not sure if that's being deployed somewhere. Yeah, so you can see some recent commits done to the Git. So basically, every DFSP can receive its own Git repo, Git organization, basically, where he can operate, or where system integrator can support at some level support the software. But at the same time, developers can connect to this Git repo and provide the updates, and the system integrator can just push those updates while selecting the profile with the up-to-date version. So like migration, for example, from Mojaloop 16 to Mojaloop 17 can be done with a single button click for the whole fleet of the nodes, for hundreds of DFSPs across the the Mojaloop ecosystem. So yeah, so just to show you how it looks like in real. just quickly to just share my small stand. Share. So yeah, so these are one of the nodes you can see. Yeah, so they are really small, and you can see they are working from the power bank. So the whole idea of this deployment is that it can run fully offline for the entire day. It can cache transactions, it can provide the service, uh, you know, even like for offline operations. And when the internet or the power comes up, it can synchronize. So these two nodes, like they are running from this from this small power bank, and moreover, like this is not only the only form factor we support. Another form factor is the tablets. So these are the headless nodes, call them like Edge Node A3. This is just a model. So we also have another form factor for a specific use case where you need direct direct user input. So the tablet basically runs the same hardware architecture that we use on these devices. It runs the same stack. The software and the hardware is the same, but it's just with a screen. It's like a 10th inch tablet that some agents or a person who wants to do KYC or even to work with the Mythos directly from the tablet, you have your DFSP in your hands basically with the tablet. So it's capable of running the whole stack, the whole DFSP stack, on the single tablet. So yeah, this is just like two form factors. Those are the headless ones for those that don't need the screen, and also there is a one for like with a screen. But the delivery model, like a hardware as a service and the software as a service, stays the same. The updates, the supports, everything stays the same. So yeah, so that's basically what the platform looks like, what it can support. So unfortunately, the video I recorded for the full onboarding it got on another computer, which I don't have enough power to power on it. But the whole onboarding process only takes probably just I don't know, probably a minute. So system integrator just push the profile, DFSP receive everything, it connects, receives all the credentials, and the Skynex platform actually can support credential sharing if needed. It can act as the identity provider because we already have the secure boot at the hardware level, and we just evolve this further up to the cloud infrastructure. So if you trust the devices that you run, and they are like trusted, they are hardware locked, and then the keys that that are used for those devices are also trusted, considered trusted. So all this equipment, all this solution ensures that there is no leaks in credentials because credentials are generated right into the devices. They are not exposed anywhere. The exchange of keys, I mean, there are only public keys exchanged, and you are sure, always sure, that the public keys are coming from the trusted source, because usually you might not be sure of whether the public key is actually coming from the trusted party and not and was not just intercepted. So having this trusted solution from the hardware up to the cloud guarantees that the platform can provide the level of security and the requirements that even financial sector demands. So yeah, so this is briefly briefly um, the platform. Any questions?
Yeah, I have a quick question, Yev. So you showed some low-end hardware. How big can the Skynext hardware platforms go? I know talking to you about this before, you've mentioned some larger nodes and
Yes. So the
clusters of
nodes,
larger nodes.
yeah, thanks. So the nodes can be sized from small ones like 4 gigs of RAM, 4 CPUs, up to 32 gigs of RAM and 8 CPU cores each node, and you will get at least 2 nodes of these. And the nodes can be spun up to 8. It can be equipped with the NVMe storage with 10 gig of network
Yeah,
switching and 10 gig of uplink. So I mean, it can even support. So we supported in Ukraine here. We supported quite heavy cluster workloads. I mean, that usually runs on the Xeons or Epics.
okay,
So yeah, so this
cool.
solution is quite capable and can scale like up and down as you want. So you can just like if you want to scale up. The process is really simple. You can just request this, and the devices will be just swept. You
Yeah.
don't need to think about, whether I need to buy anything new or not. So we just provide the platform itself, and you think about, the business.
Yeah, understood. Okay, thanks. I see there's a question in the chat there. Can I use the device with my own Mojaloop deployment? So this is
Yep.
for the DFSP side, right? So um, you're, I'm guessing that the Skynex platform allows you to configure the devices to connect to any Mojaloop switch, right? So
Yes.
any scheme operator. You don't
Yes.
actually host a Mojaloop switch yourself, right?
Like you decide what to run on these devices. So
Okay.
you can run like anything. So we just provide the platform. And the platform comes with the bunch of add-ons. It can act. So we also have a so-called trusted proxy, for example, that doesn't even require you to establish a secure connection on your services. So you just access some external service, your service, for example, but
Yeah.
external one by HTTP. And the platform wraps everything with the MTLS on the Skynex control plane on the cloud. There is the identity provider running, basically the CA,
Yeah.
that your server can check whether the device that tries to connect to you is trusted. So you reach to the Skynex CA to validate the JWT certificates, for example,
Yeah.
And those certificates are automatically generated by the device. So device just wraps all the outbound connections with the encrypted MTLS and signs requests,
Okay.
and trusted by our CA.
I think I understand. So if let's take an example of someone we know who's live with Mojaloop. Let's say Rwanda. So let's say there are DFSPs in Rwanda who want to connect to R switch. They could use your platform to connect to the R switch Mojaloop, right?
Yeah,
Yeah,
easily.
understood. Yeah,
Yeah.
understood. Thanks. Okay, that clarifies.
Yeah. So just to quickly note, in terms of the components that you need to support, for example, Vault, Istio, again, like the authentication layer on every service, the identity provider, authentication, all these methods, they are already covered. So you can just pick, the add-ons that device can run. Everything is run in fully hardware virtualized environments. So everything is separated on the hardware level. Those are not like container runtimes, but those are like virtual machines, basically, but very, really small virtual machines.
Using so the ARM CPUs provide that sandbox environment, right?
Yes.
Understood.
It has
Okay.
the trusted execution environment as well. So the root keys, the trusted keys, nobody can access them. Even root user, even if you have root for some reason,
Yeah.
you won't be able to read the keys because they are hardware read protected. So only CPU
Understood.
can read those keys and decrypt the data with those keys. So
It's a built-in HSM basically, right?
yes,
To the
yes,
CPU
yes,
core.
yes. So
Yeah. Okay.
we chose the particular platform, the hardware platform that would allow us to leverage, those kind of security requirements.
Yeah.
Because most of the, Intel, other things, they are known to have some backdoors. Raspberry Pi, it has closed source firmware running on the GPU,
Yeah.
actually, and it doesn't have the secure key storage. Other type of single board computers, you know, those
Yeah.
are just like toys. So
Okay.
yeah, so we wanted to provide some, enough level of security, and we even performed penetration testing on the device with the hardware volt injection
Mhm.
to understand whether we can extract some sensitive information during the encryption. So you
Mm.
might know that even if you have fully encrypted device, you can guess the encryption keys just by the side channel attacks.
Yes.
Yeah,
Yeah.
you can listen to the voltage levels here and there, and yeah, so it's
Yeah.
kind of
Got you.
interesting, but yeah, so not every device has enough protection against side channel attacks
Got
when
you.
you actually have the device, when the attacker actually have the device in their hands.
Yeah.
So it's really important to also think about that.
Okay, thanks. Just I see Miller's got his hand up. Just one last thing, right? So in the version of this that's the Mojaloop scheme onboarding, running on the hardware is the Mojaloop connector, a core connector, and all the
Mythos.
supplementary services, right? And Mythos
Yeah.
as well.
Yeah.
Okay, got
I mean,
you.
it's all run everything, like all the DFSP stack.
Got you. So it's
Yeah.
DFSP-in-a-Box, hence the
Yep.
title. Right.
Yes.
Okay. Okay. Hence the title of
Yes.
the presentation. Thanks.
Yes.
Thanks.
Yes. Yes.
Thanks.
It's fully DFSP-in-a-Box.
Thanks. Go ahead, Miller.
Oh, thank you. Hey, yeah, this is great. Really great to see this. Thank you so much for this work. I have a couple
Thank you.
questions, and then I want to be sure we get to Monzi's question as well. In particular, as we're talking about the use of the TPP for secure boot, so you can chain from basically a lump of hardware all the way up to a running secure node, an edge node. Part of that is the provisioning of Mojaloop key material. It looked like in your presentation you talked about the provisioning of the JWKS and other forms of the JSON key structures. But I think we also have to generate the signing key pair that's used in the quotation service for Mojaloop. I think that is done, correct me if I'm wrong, James, but that's done in the core connector. It used to be done, there were two pieces in Mojaloop. One of them was responsible for some of that, the scheme adapter or something like that. And then the other one was the core connector. I don't recall where that's done. I think they've been merged now. Does that implementation, though, have access to this local key storage in a way that, for example, you can direct key generation and key rotation securely on device, and then you can ask the device to securely sign or generate a signature or a digest or what have you that we need for our quotation service? I hope that
Yes,
question
exactly.
is clear.
Exactly as you understood.
Okay, thank you.
That's the level of security we are aiming to. So we don't expose the keys directly to services. We provide the service for other services to
Yeah.
to use, right? To sign
Yeah,
them.
that's what we want to see, is that the services that Mojaloop depends on are generic FIS, uh, they're basically secure services that everybody understands, and they're well standardized. But the interface to those from the Mojaloop software is sensitive because we're asking it to do something on behalf of the end user, in this case, the financial institution, to authorize a payment. And we have to be sure that that authorization flow itself is secure. And so I want to understand a little bit about that. So obviously you can't modify the software running in the device because
Yeah.
the secure boot platform would prohibit that. There are certain other aspects, though, and I think it would be interesting over time to have someone look at the pen testing on this device environment and say, here are the assumptions about the physical environment that would give you some satisfaction that this is working well. In other words, is it a level 4 style device? I could throw it in a parking lot and put big signs that are pointing at it and saying, have at it, and it's still secure. Or does it have to be in an insecure environment? Does it have to be an environment with reasonably controlled temperatures and that kind of thing? Or is it an environment where I actually have to have it in a locked environment with man traps and that kind of a thing? So we'd want to understand the kind of layers of security that assume this device in reality. It doesn't have to work in all environments. You can say, look, it is a banking system. So if they're prepared to run their core bank system there, then we probably want to say that that's around the level of security that we're interested in. But not all of those environments, as you said, if they're just Excel, are going to meet that requirement. So I'm interested to see how that shapes up. Along that line, though, and this is to Manzi's question, can we run not just the Mojaloop node on this, but could we run the PISP endpoint on this? And if so, how would that price out? I think I understood your presentation that it's $25 per month for, is that for a node, a single node?
This is for 2 nodes.
Okay.
This is quite actually like 2 nodes, 8 gigs of RAM each. So might be enough for most deployments. I mean,
Yeah, I
full
expect so.
CPU cores. Yeah, so you have like total 8 CPU cores, 16 gigs of RAM, and for like $25. If you go higher, obviously, I mean, the price might be a little bit higher. It won't be like twice, but like the gradation is really like it's not steep. So you sure can run like any kind of even server enterprise grade software, let's say, on this.
And how does the
And
how does the FSPs get involved in this? So if let's say, for example, a systems integrator who is also an ISO for a particular market. They're providing point of sale terminals and that kind of thing. They have an established business that interfaces between large and small merchants and a variety of networks. Could they become one of the SIs for this solution then? And is there a strategy that's in place between Skynex and that community? How would they go about onboarding into that?
Yeah, so we encourage integrators into this, if I understand you correctly. So they are the final, the last mile between us and the customers. And so they just got everything. Like they got the control over the devices they want. I mean, the application of profiles, configuration of them, deploying anything they want. And we just ensure that nothing will break on the device. And so we also had the use cases, by the way, to support point of sale terminals, the self-service terminals, basically with the point of sale feature. So you can think about like a large screen with the some menu. You can pay with the device with the connected device inside, and we also run like answering to your previous question about the environments. One of our use cases were the e-ticketing system here in Ukraine. So we participated in we run the pilots for e-tickets in public transport, which is famous not to be very friendly environments, especially in winter. And so everything is shattering, like everything is shaking, right. And you can think about like we tested several hardware solutions, and we noticed that even USB ports were disassembled at some point because of this, continuous shaking. So so we tested that in different environments.
Fair enough. Well, this is great. I think if I have, then I'm going to make sure we get to Manzi's question as well on the pricing side. But importantly, some of the software running in this isn't yours. It'll be developed by the systems integrator and by others. They need to service that software. And so we want to understand what is the process by which they go through the continuous integration, continuous deployment and testing. They obviously don't want to push the software out to a network of 35 outlets and see that it's broken. So they would have to have access to the device for their own testing purposes in-house. Having done that, then I presume your system would push the new updates after signing it out to those devices. Do I have that understood correctly?
Yes, completely correctly.
Okay,
so first you have the staging environment where you can test your software. You can have it even right next to you. You can even work offline with that. We even support use cases where you can just disconnect everything and just work with the device over the Bluetooth. So this is quite an interesting use case. Was like to support the IoT, one of the IoT customer that wanted fully offline, fully air-gapped environments, but still wanted to upload the software and test it. So so you can surely test that on any number of devices. I mean, like 10 or whatever. And after successful attestation of the software that it runs as expected, that the resources are not exhaust, like that the resources are enough for this setup, you can just release it, like tag your release, whatever you use, like Docker. I don't know. We support different kind of workloads, even some legacy ones, even Windows let's say, core connectors that legacy banks have, and they only run Windows on Windows machines as the
Windows
applets.
XP is the preferred platform for the banks. Yeah.
Yes, yes. So we also supported
kidding, of
one of the
course.
use cases for that. You know, the ActiveX applets, all this
Yeah.
stuff.
Right.
So yeah, this is one of the
Okay.
use cases, and
Well,
was
that's
also
great.
working.
Awesome. Thank you so much. I'm cognizant of time here, and I see Simeon keeps popping on screen, which usually means he wants me to stop talking. I did want to be sure that Manzi had his short question addressed. Manzi, did you want to?
Yeah, I was going to ask you if you can respond to Manzi's question as we wrap up. Can PSP use this hardware, and if yes, what would be the pricing?
Yeah, so they surely can use this hardware. Regarding the pricing, that depends on the requirements, but I doubt that it will be, you know, I don't know, like a lot for some. Like usually we didn't have deployments that require the huge amount of compute power, and usually clients not pay more than like $50 per month, you know, for really like powerful compute cluster of several nodes. So yeah, I mean, for sure, the PSP use case is possible.
Okay, thank you, Yev. My question is the recurring fees and the initial fees, because I have a demand already. So if I'm going to respond to them, probably we set another session with you, and
Yeah.
that one is pressuring actually. Thank you.
Yeah, yeah. So
Okay.
so the thing is, you don't need upfront investments into that. This is the biggest thing, the biggest factor usually from the customers we saw. Usually nobody wants to pay upfront, so having something that you can just use and then you know, cancel anytime looks really nice.
So you mean even the system integrators are not paid? Are not paid by the someone who wants to
Only the end user. So only the customer that runs the actual compute environment, compute setup, right?
Okay.
So we don't charge system integrators because they are you know, providing customers or providing support for customers. And I mean, we let's say we target our platform differently than usually others targeted. So we've been working in Ukraine for quite some time with this platform, and you know, our conditions are you know, they makes you to sacrifice lots of things to succeed. So
Thank you.
Thanks, Yev. You have any final comments you want to wrap up with?
yeah, I mean, thank you for the opportunity to present today. It's been pleasure actually and honor. So
Awesome.
thank you.